racing through the hallways at school. To make things a little bit more interesting, you take off your shoes, your friend leaves theirs on, giving you a coefficient of friction with the ground of only 0.2, and your friend, because they've got their sneakers on, has a coefficient of 0.65. The question is, how fast can you both go, given that the radius of the turn you're about to take is 5 meters? Well, the first things first, we need to just realize what is the centripetal force acting on you when you're running around a turn, and that would be the friction between your feet and the ground. So what we would end up with here is the force of friction is the centripetal force. Now we need to figure out, well, what equation do we want to use for centripetal force? Because we're looking for velocity, I'm going to use the centripetal force equation that has velocity in it, which is mv squared over r. Now I'm saying, wait, I don't know how to solve for the force of friction. I don't have force of friction. I have the coefficient. That's okay. Here's what we would get. We can break down our force of friction equation into its what makes friction up, which is mu times the normal force. And the right side of the equation remains unchanged with mv squared over r. Now if we look at it, we have the r, we have the coefficient, we're looking for the velocity, but we don't have mass and we don't have the normal force. So what are we going to do? Whenever you have a mass in your equation, but you're not given the mass in the given stuff in the problem, chances are the mass is going to cancel out. Well, where does the mass cancel out in this situation? Well, if you look at a picture of somebody running on a flat surface, force of gravity pulls them down, the normal force lifts them up. Those two things have to be equal because the person is not accelerating up and down. So that means that our normal force is going to be equal to the force of gravity, or the normal force equals mg. And the right side is still mv squared over r. Since I have mass on both sides in the numerator, I can divide it out, and it's gone. And that will leave me with mu g equals v squared over r. Now I can rearrange the problem for v because I have r, g is 9.8, and we have the coefficient for each you and your friend. So that gives me the square root of mu gr equals v. Now we just have to plug that equation in with our numbers for each problem. So if I do the square root of mu 0.2 times g 9.8 times r, which is 5 meters, that will give me a velocity of 3.13. And that's for you because we use your coefficient. Now for your friend, we'll use purple. Same equation, just slightly different numbers. So instead of 0.2, it's 0.65. 9.8 is still 9.8. And it's the same turn, so that's 5 meters. And when I plug that into my calculator, your friend can go 5.64 meters per second.